Is the absorbed components of a substance, for example, water and oil.
Homogeneous. This mixture has all its common
Characteristics, differences, and properties. These have the purpose of knowing deeply about the topic with examples.
measure in this cup. The second one is 50 milliliters of water. The third one is 5 grams of salt and sponge. It's very important. You need 3 or 4 strawberries, 10 milliliters of ethyl alcohol. Then you need a glass or a plastic cup. It's very important because you need to see all the procedure. You need a plastic bag. It's very important because you need to push the strawberries. You need a stick, kitchen jug, and for finish you need a toothpick for extract the DNA. That's all, and we can continue with the procedure. Thank you.
Mixing up the washing up liquid, the water and the salt will create a mixture.
That will help break up the strawberry cells when we smash them and release the DNA contained inside of each cell.
Step 2. By passing it all through the sieve, we get rid of solid debris.
The bolt case used to pull the DNA out of a mixture. DNA is not soluble in alcohol, so it's precipitated out of the white clumps that we see in the top layer.
For the experiment, we did not find difficulties, since it only consisted of the first mixture helping to combine with the fruit, in this case, the strawberry. In this way, when straining the liquid plus the cold alcohol, it will result as two divided substances, and the top part turned out to be the DNA.
Inorganic chemistry is the one that studies the inorganic chemicals that are found in lower proportion than the organic ones, and they are generally divided into bases, acids, and oxides. In this video, we will only see acids and bases. Acids are chemical compounds that are soluble in water. They always will have a hydrogen ion, and they will be corrosive to the skin. And in the other side, we have bases. Bases can accept hydrogen ions, and they can neutralize the acids. And how do you know if they are acid or base? You can know this because thanks to the pH, the pH gives us the information to know if a substance is a base or an acid.
The purpose of this video is to inform and explain what pH is, what is the pH scale, how it works, how to know the acidity or the basicity of a substance, also to inform what's the difference between the acids and the bases, how they react, and we also show an easy and natural experiment to discover if a substance is an acid or a base.
We also want to prove to our viewers and ourselves that our experiment actually works, even if we use simple and cheap ingredients as it is the red cabbage. As well, we want to make a very informative video with the best quality we can offer.
So how can we identify an acid and a base? Well, there's an easy way for doing this, and we just need litmus paper. And as you can tell from the name, the litmus paper is a kind of paper that works for identifying this kind of substances. We just need to immerse the paper on a solution, and if the paper turns pink or red, that means the solution is an acid. And if the paper turns blue, that means the solution is a base. And this is an easy way for identifying acids and bases.
An acid is a chemical substance which contains hydrogen and can react with other substances to form salts. There are three main theories that explain acids in a chemical point of view. The first one, Bronsted-Lowry, define acids as a substance that can donate a proton. Jean Louis proposed that acids could be electron pair receptors. And Arrhenius defined acids as a chemical substance that contained hydrogen and if dissolved in water could cause great concentrations of hydrogen.
Some characteristics of the acids. Well, one of the characteristics of the acid is that they have a sour and acidic taste when it's consumed. They also can conduct electricity. They can change of color from a blue to red, and they can react to a base to form salt and water. Where we can find some acids? We can find acids in products like vinegar or ketchup, in fruits like orange, lemon, or grapefruit, and in some other dairy products like eggs and milk.
Are those substances that can capture hydrogen ions in solution or release negative ions called hydroxyl. In other words, bases are defined as those substances that contribute 2 electrons to the solution, following the theory of Gilbert Newton-Lewis. The bases don't react to contact with metals, and also when they are mixed with acids, they produce water and salt. Some examples of there are baking soda, toothpaste, and soaps, etc. There are 2 types of bases, weak base and the strong base. A strong base refers to a variety of electrolytes that can be ionized in an aqueous solution, and a weak base refers to those bases that do not fully dissociate in aqueous solution.
The general idea of this workshop is to use the use of the red cabbage to measure the pH of various substances. Also, this workshop has some purposes, such as the first one is to show through an experiment how acids and bases work and the reactions. The second one is to understand the main differences between the acids and the bases. The third one is to identify the main chemical characteristics of each of these types of substances. And the last one is to identify the main acidic substances and their fundamental chemical characteristics.
Experiment, we're going to be using these materials: a red cabbage, a little bit of water, vinegar, and laundry detergent. First, peel off 4 cabbage leaves and put them in a blender with 1/2 of water. Blend the mixture until you have a purple cabbage juice. Filter the juice in order to have a pure liquid. Here you have it. Divide the juice in 3 glasses.
Now we need to add a little vinegar to the first glass. Now you will observe how it turns red. All acids will turn red when mixed with cabbage juice. We add a little detergent in the second glass. You mix it with a spoon. You will notice how the liquid turns green, indicating that this is a base.
When we finish this experiment, we can observe how it was the one with vinegar, the one with detergent, and the neutral one.
So we know that the pH scale is column from 1 to 14. The values are 1 to 6 is acidity, 7 is neutral, and 8 to 14 are basicity. And anyone can see that, but can be cabbage with different substance. In this case, we use vinegar, lemon, sodium, bicarbonate, and ammonia. And anyone can know the pH by its color. If it is pink, are acid, and if it is green, blue, or another color, are basic.
Hi, my name is Luis José Tarango Collado, and my team and me we're going to explain the crystallization process. Let's talk about the ingredients. We will need a glass, some pipe cleaners, sticks, and of course, borax. First, put some borax in the glass. It should be noted that the size of the glass doesn't matter, and the amount of borax can be more than 2 tablespoons. More borax, more effect will have the experiment. Then, with the sticks and the pipe cleaners, you're going to make the figures that you want. Preferably some figures that are easy to make, like lines or circles or something like that. For the next step, you're going to boil the water. There's no defined temperature, so only sure that the water is so hot. Alright, now we're going to serve the hot water in the glass with borax. Perfect, now mix well. We're going to make it like an homogeneous mixture. We'll let it rest for a long period. It can be from 1 day to 5 days, while I will explain why the crystals are generated. Borax, sugar, or salt have some properties that when in contact with hot water, they start dilating and paste to the solid object that they have closer. And here you can see some examples of the final result of the experiment. There is a variable that instead of use pipe cleaners, we use thread, and instead of borax, you can use sugar, but there's the different reaction. Here are some examples of that variation in the experiment. As you can see, the crystallization is similar, but is bigger and with another form. Excuse me, teacher, I got a question. Yeah, of course. Tell me, what happened? What is the definition of crystallization? Well, that's a nice question. Yeah, I know that is a good question. That's why I asked it. Oh, Charlie. Charlie? To answer that question, only see this video.
Crystallization is the process by which atoms or molecules are arranged in a rigid and well-defined crystal lattice to minimize their energy state.
You have it clear now? Oh, got it. And now, my teammates and me, we're going to give our opinion about the experiment, and we're going to give the experience that we have making it.
Well, what I learned during this project was that crystallization is actually a really cool and really interesting process. And if we watch it really slow, if we analyze every single step, it's actually really interesting, and it's actually really easy to do, which is it's cool.
What I learned about this activity
is that the crystallization is a process that it not only involves sand, like I think it, because I think that only sand and fire to join it and it becomes crystallization. Now I can see that with borax and with other elements, we can do the process of crystallization. That's what I understood.
Well, I enjoy to do this project because this showed me a lot of things that I haven't known about the salt and the borax and how they can be mixed and how they produced the crystals.
Okay, what I have learned from this experiment is how does the crystallization function and the different ways that crystals used to grow. Also, the process and the time that it follows. I learned the last year about different types of solution, but when I was searching information for the experimental activity, I read new information that I have never expected. For example, how does the saturation levels can affect the rate in which crystals are formed.
Well, I already made this experiment on third grade, but I didn't make it with pipe cleaners. I make it with the thread. And was different to see how the crystallization makes with the pipe cleaners because I don't know, it's a different type of view, it's a different experiment, but it's so similar at the one that I already realized. So I don't know, I just get fun and understand things that I didn't understand in the past.
In this experiment, I learned how can we form crystals, also the kind of mixture that we get, and why if we mix those things, we get that result.
Hi, hi, I am Jorge, and I will say you what it was incredible for me in the experiment. Something that I like a lot is that the easy way to make a crystals in the house, because we only use two ingredients that was the water and the borax, and it was too easy. For me, in my experience, I don't mix it a lot the borax with hot water. I use not the water was not boiled, and what something that happened to me it was that the the glass that I use in the bottom, the crystals were formed in the glass, and that was something that for me was incredible. But and I like the a lot of the experiment because we also can see that we can use many colors to mix and do the crystals with like green or blue and you know and that's incredible. Thank you.
All talking about acid rain. Things like the concept, how it's created, how it's emitted, different reactions, how it contributes to the pollution, of course, our experiment. Now I leave you in introduction with my partner, Anya Mariel.
I will give a small introduction about acid rain and the relationship that we will analyze between water from different sources in terms of its pH value. We know that acid rain is a chemical process where the pollution goes down by rain. The rain needs components to be considered as an acid rain, sulfuric and nitric acid. Acid rain contains substances that can modify the pH in some supersurfaces, such as lakes, stagnant water, and puddles. We are going to do some experiments where we will analyze the quantity of the pH value within different water sources. So let's start.
The materials are glasses, distilled water, rainwater from different parts like rain, puddle, salty, and citron. Purple cabbage solution to prepare this solution you need to boil it, since without the ingredient we could not get the pH from the water. And finally we will need a potentiometer to have the pH ready and document that.
To see how the pH is different in every type of water, we have to do the following steps. First, pour our solution in a jar. Then, separate our types of water in different glasses. After that, we have to put a little bit of our solution in every type of water. Then, wait a minute to see how the color is changing. Finally, compare our results with the table of pH. The result of the experiment was that all the waters that we collected were alkaline substances, because if we observe in the table of the pH, the color blue is located in the alkaline side. Then if we looked at the table, we can observe that they are acid substances. And when we put the chart inside all the substances, we observe that they melt fast.
For the second project, the team used 3 glasses, 3 chalks, vinegar, lemon juice, and water.
That the water change depending of the type of pH they have. They change color to purple and different type of blue. In majority obtain an alkaline pH. In conclusion, acid rain is an environmental phenomenon that can be caused by the poor treatment that we humans are giving our planet. It affects the vegetation because it removes essential nutrients, so that plants and trees do not have this and they become more fragile to pests. Acid rain negatively affects the environment and can also affect people's health. They can cause respiratory diseases such as asthma or chronic bronchitis.
Thank you, Dana. Well, this was Dana with the conclusion. Unfortunately, we gotta go. Thank you so much for watching this video. I hope you like it. We spent hours trying to research about acid rain. This was hard work. Hope you like it. Thank you, and see you in the next.
Starch and food. This is a team 5, which are formed by Nicolás, Paola, Jimena, Eric, Juan Daniel, Matilda, Danae, Andre, and Alexa. With this video, we want to show how we can know the percentage or if is any starch in the food. Also discovering the benefits that make us to our body and how it used for, what it used for, and at the same time we understand how does this process function.
But what is starch? The answer to what's starch is that it is a chemical compound. This chemical compound is made of 6 atoms of carbon, 10 atoms of hydrogen, and just 5 atoms of oxygen. This compound, or this starch, is white. It's like cream, but it has a different texture, composition, and many other things that is a difference from cream to starch. It is also tasteless. This means that if you ate it, it will not taste anything. It would be just like water that doesn't have any taste. It's just mucus, just that. Starch, starch can be found on plant-based fruits and vegetables in every plant. This is because plants will produce starch. So this also means that we cannot find starch on animals. And if we can find starch on animals, it means that our chicken, meat, fish, or everything that we could imagine that comes from an animal will not contain starch. In this experiment, we have decided to make. We will difference the foods. Also, we already know which foods contain starch.
Now I'm going to explain the different 3 types of experiment that we are going to do. For understand better this topic, that is the structure of food, we are going to use 3 different types of food. In this case, we are going to use a banana, a pumpkin, and bread. But why we have to do that? Because the results change depending the type of food that we use. For make this experiment, we are going to use some materials like an iodine solution that you can buy it in a pharmacy. Also, any kind of food that contains starch. In this case, you can use a bread, a pumpkin, or a banana. We're going to use water, a bowl, and a cup. Result. What are we expecting of this experiment? Well, what we expect of this experiment is that the food change color into a dark blue in order that we can know if there's any starch because of the previous reaction that we explained.
Okay, my name is Jimena and I'm gonna do the experiment where you can see the starch in the banana.
going to see starch in zucchini.
Hello, my name is Nicolas Alexander Petesen Abreu, and I'm going to do an experiment to check if the red has storage.
Contrary to popular beliefs, starch does not cause weight gain if it consumed moderately. Once digested, it acts like dietary fiber, which protects the intestinal flora from bacteria, prevents constipations, and improves circulatory system, among other functions.
Starch, besides providing energy, is also a good source of proteins, minerals, and vitamins. It's also mentioned that it is good for the immune system and it helps to fight toxins.
In conclusion, the experiment had the results that the team expected at the beginning. As we can see, the iodine dissolution will react to the starch in our food, and because of this, the food will change into a blue dark color. And if the food doesn't have a starch, the food will not change its color. This is a very easy way to know about an approximately quantity about the starch in our food that we eat in our daily life. This is a very easy experiment that we can
Reactions are part of our day-to-day life, even though of us cannot perceive or understand them. Examples of these are the fermentation, combustion, and correction or oxidation of the metals. Others of great importance are those that occur in the organisms of all living beings, in order to provide the body with energy and then store and consume it. These kinds of reactions are indispensable for life. Now, what is the chemical reactions or how they are carried out? And in this, there are two types of reactions, which are exothermic and endothermic. At the moment, we will talk about the exothermic reactions. That will be those reactions where heat is released. And for this means that the energy of the molecules of the products EP is less than the energy of the molecules of reactions ER. In exothermic chemical reactions, heat is released, DH, is negative and means that the energy of the products is less than the energy of the reagents. For example, in the combustion of reactions. And while these are produced, we can observe that during chemical reactions, energy absorption or release may occur. This indicates that both reactants and products contain heat and in this characteristic of their mass. The heat content is a measure of energy that is accumulated by a substance during its formation.
Endothermic reactions. To understand the concept of endothermic reactions, we must review the words in Greek: endo, which means inside, and therm, which means heat. In general, endothermic reactions absorb energy from the surrounding environment, usually in the form of heat, and is getting constantly absorbed. The energy absorbed provides action for the reaction to occur. These reactions lower the temperature of their surrounding area, thereby creating a cooling effect, like cooking food, melting an ice cube, or the ozone production in the atmosphere.
Our general objectives: to identify and improve our knowledge and understanding about exothermic and endothermic reactions. Specific objects: to improve our skills of teamwork and also to coexist with our classmates, to engage our relations as a group, share the acquired knowledge with our nearest classmates and teachers, to demonstrate these endothermic and exothermic reactions through an experimental application, knowing the uses and practical applications of endothermic and exothermic reactions on our daily lives, to promote and disseminate scientific knowledge, and to enable others to learn more about this interesting theme.
Hydrolysis, a very easy, economic, and safety experiment. For this experiment, the electrolysis or hydrolysis will try to grow the molecules of the water. For this, we will need, of course, water, the still water that doesn't contain any type of ion. Then we will need sodium bicarbonate. We will need a topper, a battery. It will be of 4 volts or maybe 9. In this case, is of 9 volts. 2 clamps and 2 pieces of graphite that you could get from a pencil, and a spoon that we will use for mix the water with the sodium bicarbonate. For first, we will add the water to the topper.
After having mentioned the materials, our teammate begins to pour the water over the container where the reaction will take place.
Then, we take the 2 pieces of the graphite and put in each clamp. Now we have it. We connect the 2 clamps to the battery. And then we put the 2 electrodes of graphite in the water.
In a few seconds, we will notice that nothing happens, and he will explain why.
As we could see, nothing is happening. Why? Because the water actually doesn't conduct electricity. For the electricity gonna be conducted by the water, we will need the sodium bicarbonate. And we add it to the water. We mix it, and then we put the 2 electrodes of the graphite in the water solution. As we can see, bubbles are being released from the 2 clamps, depending on the positive or negative electrodes. The different oxygen and hydrogen will be attracted to the 2 different electrodes, and this is hydrolysis. No? That's all.
The purpose of this experiment is to separate hydrogen and oxygen from the water using electricity. As we know, water is composed of 2 atoms of hydrogen and 1 of oxygen that are united by a covalent bond. This reaction between hydrogen and oxygen is known as an spontaneous reaction. That means that it happens naturally. This is because the energy of the final state is less than the energy of the initial state. That means that hydrogen and oxygen tend to get together, but we can separate them adding energy to the final state. To make this possible, we need to make an oxidation reduction reaction. What are we going to do is to use a liquid that allows the pass of electricity, that when we put two electrodes, the electrolytes will travel to the negative and positive poles, completing the circuit. The ions of the liquids will release as solids, liquids, or gases through the electrodes. In this case, hydrogen tends to receive electrons traveling to the negative pole, and the oxygen tends to give electrons traveling to the positive pole. H2 and O2 will be formed in each pole respectively. In the end of the experiment, we will see the liberation of these gases.
So we're going to do the exothermic reaction. So this is going to do of 1 tablespoon of bicarbonate of sodium, like 1, and there's 1. Then we're going to put vinegar over the balloon, and the exothermic reaction is going to put it like a balloon, and it's going to inflate. But we're going to wait over 1 week, and the result is going to do like an exothermic reaction.
Okay, first here my friend is going to do an exothermic reaction. He first adds what is that, bro? I think it's bicarbonate sodium. I don't know. Then he adds a little bit of vinegar. Yeah, I think that's vinegar. He adds both of them inside the balloon because he says it's going to expand. I don't know. He seems like he knows what he's doing. That's kind of cool, bro. But after adding those ingredients, let's see what happens to the balloon. As we can see, the balloon is going to expand a little bit. I don't know why that happens, but my teammate is going to explain that.
So this experiment is an exothermic reaction, which we can define as a chemical reaction that releases energy, which can be in heat or light. For this experiment, we will need a balloon, a small spoon, vinegar, sodium bicarbonate, a funnel. The steps are pretty simple. The first thing you will need to do is to put the balloon in the funnel, and after that you will need to add 2 small spoons of sodium bicarbonate. After that, what you need to do is to pour some vinegar inside of the funnel so it will be in the balloon and it will start to inflate. But why does this happen? This is not only an exothermic reaction, but it's also an acid-base one. When you combine acid, which is the vinegar, with a base, the bicarbonate, a salt and a gas will be created, which is why the balloon inflates. After we mix them, energy will be created as heat. That's why the balloon inflates that fast. These kind of reactions are really common since most of the energy we use is burning materials, which are known as fuels. So technically what happens here is that when we combine vinegar and carbonate, energy will be realized as heat. That's why the balloon gets inflated.
So, a chemical reaction is a process in which one or more substances called reactants are converted to one or more different substances, which are called products. Substances can be chemical or elemental compounds. We saw specific reactions in this experiment. Then we can conclude that the endothermic reactions are used to break bonds in reactants, and energy is released when new bonds form in products. In this reaction, it takes more energy to break the bonds in the reactant than it is released when new bonds form in the products, as we saw in the hydrolysis experiment. And in an exothermic reaction, chemical bonds are formed, so the energy is released into the environment instead of being absorbed. We can see this in the reaction of combustion of propane gas experiment.
Hi, my name is Daniela Romero Villagran, and the chemical element I choose is the helium. The helium is named for the Greek titan of the sun, Helios. Its atomic number is the 2, its symbol is He, and its boiling point is the lowest among all elements. It was the first noble gas in the periodic table and the second lightest and most abundant in the universe. It was discovered by the French astronomer Jules Janssen along with Norman Lockyer. The formal discovery of this element was made in 1895 by two Swedish chemists, Per Theodor Cleve and Niels Abraham Tanglet. We can observe helium commonly in microscopes, in supermarket barcodes, in the filling of balloons, and more. And these are some things about the helium.
What is the periodic table? The periodic table, also known as the Mendeleev's table, it is the table of the chemical elements existing on the Earth. This table is organized arranged with chemical elements according to their number, properties, and characteristics. This is composed of 180 line elements confirmed by the International Union of Pure and Applied Chemistry, the UPAC, of which 94 elements are from the nature and 24 are synthetic elements. It helps the scientists to understand the world around us. As my example, I choose potassium, that is represented in the table with a key. We can find it in the vegetables that we eat in our normal life.
Organization. The chemical elements are arranged according to their properties from left to right and from top to bottom, in decreased order of their atomic numbers within each element square information or on the element symbol, atomic number, atomic mass, electronegativity, electron configuration, and valence numbers can be found. At the bottom of the periodic table, it's a two-row blocks of elements that contain the lactanides and actinides. This group are classified in an inert translation metals. This current periodic table is structured in a 7-row horizontal called periods and 18-column vertical called groups or families, and they are composed in the next order. Group 1, alkaline metals. Group 2, alkaline air metals. Group 3, scandium family. Group 4, titanium family. Group 5, vanadium family. Group 6, chlorine family. Group 7, manganese family. Group 8, iron family. Group 9, cobalt family. Group 10, nickel family. Group 11, copper family. Group 12, zinc family. Group 13, earthy. Group 14, carbones. Group 15, nitrohenoids. Group 16, chalcogens or amphigens. Group 17, halogens, and group 18, noble gases. And we can find some of these elements in our early life, like the copper, that his element symbol is Cu, and his atomic mass 29, and we can find it in chargers or in cables.
Metals, nonmetals, and metalloids. There are three categories of the elements that make up the periodic table, and they can be distinguished based on their chemical and physical properties, which are metals. They are solid elements, minus the mercury that is a liquid state. They are malleable, ductile, shiny, and good conductors of heat and electricity. They are on the left side of the table. Non-metals. These are most gas. Also, there are also liquids. These elements are not good conductors of electricity and opaque. They are on the right side of the table. Metalloids. They have properties of both metals and non-metals. They can be shiny, opaque, and not very ductile. Its electrical conductivity is lower than metals, but higher than non-metals. They are found on the right side of the table between metals and non-metals.
In the periodic table, each element contains different and important information, and this information is divided on atomic number, that is the total number of protons that an element contains in its nucleus, that is represented with the letter C, that is also used to classify the elements of the periodic table, then the symbol, that is the abbreviation of the atomic name of each chemical element in the periodic table, the element name that is used to name a chemical element, or methods. Then we have the atomic mass that is named like that because it was composed by the total mass of the protons and neutrons. The electronic configuration that describes the distribution of electrons in their own atomic orbitals. Like it's the same way that the standard notation, but the first part of the configuration is expressed with another chemical element which has to be novel. And finally, the physical state, where the periodic table shows us represent with a symbol which tell us their state of matter, such as liquid, solid, gas, or synthetic element. An example of chromium will be stainless steel. As you can see, this is cutlery of stainless steel, and this is something that you use on your daily life every day, where chromium is present.
The history of the periodic table. The creation of the periodic table is attributed to the Russian scientist Dmitry Mendeleev, who in 1869 created the periodic table that we still use today. Mendeleev organized the periodic table, the elements in increasing order by their atomic masses. He even left empty spaces, anticipating the existence of other elements not yet discovered at the moment, and that should be included in the periodic table. Soon after, the German chemist Julius arranged the elements based on the physical properties. The last change in the periodic table are the work of the Nobel laureate chemist Green Seaborg, who, among other things, ordered the actinide series below the lanthanide series. Periodic tables and the elements in objects. Argon.
Iron for animals, strengthening teeth and bones. It is added to thinking water in some areas. Fluorine is made by the electrolysis of a solution of potassium, hydrogen 4 in anhydrous hydrofluoric acid. The element is used to make uranic hexafluoride needed by the nuclear power industry to separate uranium isotopes. Fluorine is the first element on the halogen group. His atomic number is 9. It's a nonmetal and is one of the few elements that can form a dynamic molecule. Fluorine is the most electronegative element. That means that it's very strong and needs very good organized elements. We can find the fluorine in the toothpaste.
Hi, I am Rodrigo, and I'm going to explain what happened after the universe was created. Well, between 10 and 6 seconds after the universe was created, the neutrinos, the quarks, and the electrons were formed. Protons and neutrons began forming shortly after that. Well, between about 3 minutes after the Big Bang, conditions began to cool enough for these protons and neutrons to form hydrogen nuclei. This is what we call the era of nucleosynthesis. Some of these nuclei combine to form helium as well. But the problem at this point was that the electron couldn't stay in orbit around any atomic nucleus because the immense heat and radiation that was floating at the universe at that time. But finally, after 380,000 years or so, the universe had again expanded and cooled enough for conditions to favor electrons staying in orbit around any atomic nucleus. And well, as we were saying, the elements are everywhere. So I search, and something so useful at these days, like our cell phone, contains many of the elements of the periodic table, like the lithium. Most of the cell phones, sorry, have lithium-ion batteries composed by the lithium oxide.
With this workshop, we will be able to know and understand better with another way of learning what was explained above in this topic and see examples of some elements of the periodic table that are found around us. For example, in the objects of our daily life, as it is the funniest way to understand the topic. The general idea of our workshop is to identify what elements we can find in the normal things of our lives and see that the chemistry can be very easy and fun to understand. All you need to do is see what elements your material are composed of and then find the element in the periodic table. Also, we will explain what contains that element. The materials that you will need for this workshop are a periodic table. It can be an image of internet, or it also can be on paper stuff or your house that you want to investigate. For instance, pencils, batteries, salt, also food and vegetables, or your bicycle. It could be a family member. Also, it can be any object of your house. For example, at the moment I have table salt, which contains approximately 40% of sodium. In the periodic table, it is represented with Na. Um, this is table salt, but there are different types of salt.
And today we are going to explain you and we are going to show you how we made an egg that when you throw it from a height, the egg don't break. But first, what is free fall? A free fall object is an object that is falling under the sole influence of gravity. Any object that is a majority is called a free falling bodies. And I'm going to tell you like some examples of these free falling bodies in the real life. Some examples in which we can get to observe the free fall are a paratrooper who is launched from a helicopter, an apple falling from a tree, drop a stone from a height, a drop that falls from the roof of a house, and a glass falling from a table.
Did you ever imagine that there exists an egg that when you throw it, it does not break? Well, yes, it exists. And I'm going to explain you how does this project consist. The project consists of launching a fresh egg in free fall from a high height and making it reach the ground without breaking it. But how we do this? To do this, you have to grab the egg with the bubble grab. So this is gonna keep the egg safe and it's not gonna break it. Then you need to make like a parachute with front back, and then you just need to let it fly and you're gonna see the results.
And what is the objective of this project? So, the objective is demonstrating in an easy way a physical phenomenon in daily life. A physical phenomenon can affect in gravity and also, well, the objects that are falling in the earth. So this is our objective, that identify a physical phenomenon in our lives and also determine the gravity
and the acceleration. So this is to using formulas the of this, and to the final product it will be the acceleration.
Our objective is demonstrate in an easy way a physical phenomenon in daily life. Also, the acceleration of falling objects is due to the force of gravity between the object and the earth. To know the value for the acceleration of gravity and to relate this.
Of all the uniformly accelerated rectilinear movements or uniformly varied rectilinear movements that occur in nature, there are two of particular interest: free fall and vertical throw. In this report, we will explain the free fall. Free fall is a uniformly accelerated rectilinear movement in which a body is dropped vertically from a certain height, represented with the letter h, without making any type of friction with the air or any other obstacle, in which the acceleration coincides with the value of gravity. On the surface of the air, the acceleration of gravity can be considered constant, directed downwards. It is designated by the letter g, and its value is 9.8 meters per second squared. To study the movement of freefall, we will normally use a reference system whose origin of coordinates is at the point from which we release the body to the foot of the vertical, as can be seen in the figure. This is an example of how freefall problems are represented. Common sense tells us that a heavy body, for example a chair, should fall faster than a lightweight body, such as a shoe. However, common sense is not right on this occasion. The fact is that if the shoe and the chair were in a vacuum, they would both fall at equal speed.
To know better about this topic, it is important to know how it all started. It is said that in the year 55 BC, Lucretius, who was a Roman and poet philosopher, explained that the speed of the object in free fall is reduced through hydrodynamic or aerodynamic resistance, and the light bodies fall more slowly because of this argument. Not, however, all bodies must decrease to the same precipitation in a vacuum. According to the belief of the Greek philosopher Aristotle, a large crowd must come to the floor more in a Jaffa than a light one, since they sink in the water while the lighter ones rise. Clearly, there is also Galileo that preferred to make his own theories through experimentation and careful observation.
Climbing freefall. Like freefall, this is only family accelerate motion like freefall. This is a motion subject to accelerate of gravity. Only now the certain acceleration opposes the initial motion of the object, which operate only downhill. Vertical throw includes the raising and lowering of bodies or objects and have the following characteristic. Initial velocity is always different from zero. As the object rises, the sign of the velocity is positive. Its speed is zero when the object reaches its maximum height. And when it begins to decide, its speed will be negative. It's a free fall during the skydiving. In some cases, the parachute opens immediately when it leaves the aircraft or fixed object, while in other cases, depending on the situation, a controlled freefall is performed before manual or assisted opening is performed. The freefall 3,000 feet to 9,000 feet, freefall developing 2,000 per hour, kilometers per hour.
The free fall is an acceleration rectilinear movement, and it is when a body drops freely. When a falling body is moving in a straight vertical line and has a constant acceleration, which is the gravity, it causes the object to increase the speed. Like, for example, if you let fall, for example, a pencil, it's going to be um, quickly, no, less quickly that if you let fall, for example, a calculator or a cell phone. because the calculator and the cell phone has more weight, and that's why it falls faster. And the speed of a falling body is directly proportional to its weight, and that's why this happens.
Finally, we are going to do the experiment. And well, the idea of our experiment is to know better and to confirm all the knowledge that was learned during all these minutes about free fall. Well, we will do this through a project, and our project is based on designing a building like a system or something to protect a egg, so that when we throw it from one high height, the egg doesn't break or anything happens to the egg. And finally, during this experiment, we will apply the idea that the momentum is conserved when the external force on a system is equal to zero. But in the case of our experiment, the momentum it is not like conserved because the external force of the system is the force of the gravity.
I am going to make the experiment. So we need one egg, one or two plastic bags, food film, cotton, scissors, cutter, scotch tape, ribbon or something to tie. For the process, we are going to pieces in the same size with the same size. Then we are going to paste it in the egg, and then with a bag we are going to tie the ribbon and two seams that it is a parachute.
In conclusion, we can see that the egg is protected by different layers of material. This causes its weight increase. At the same time, we can see that having a kind of parachute, its descent is slower, which reduces the force and the speed of his fall. Therefore, which this generates that the egg reaches the floor without problem. We can see this apply on real life on bungees and parachutes.
Hello, today my name is Montserrat and we are going to introduce you about the parabolic shot. So let's go with it.
Introduction. This part of the project we will explain what the parabolic shot is. The parabolic shot is a movement that results of the union of two movements. The movement of uniform rectilinear that are horizontal components and vertical movement, vertical components, which is affected by the gravity, and the result of the movement is a parabol. The parabolic shot has two classes, horizontal and oblique shot. Now, when we can see parabolic shot in sports, parabolic shots are possible in practically all sports that have a projectile. That can be a ball, for example. We can see a parabolic shot in football, in soccer, in volleyball, in basketball, and basically all sports that have a projectile can have a parabolic shot. But the three common sports that we can see a parabolic shot are football, soccer, and basketball.
There is a kind of shoot that has both of the moments in special cases. There are the extreme sides of the parabolic shoot, but it depends more on the place that the shoot is realized. The effect is called Coriolis drivers. It is more seen in the professional sniper shooters. It is consists on the movement of the earth and how does it affect the trajectory of the bullet. It only affects the bullet when it flies. More than 6 seconds, or in small cases, how strong is the force G of the object or place where the shoot is realized. The variables of these effects are the localization of shooters and target at altitude above the planet and azimuth of the shot. The magnitude of the drift depends on the localization of the shoot and target azimuth and time of flying. It is necessary to say that it's not an aerodynamic effect, is more important of the movement of the Earth than the projectile. But it doesn't mean that the classic parabolic shoot is not taken into account in the final results.
Our general objective as a team is to present information and explain about our topic, which in this case is the parabolic shooting. This in order to get a reachful knowledge about it and its characteristics. Our specific objectives are: know what is the parabolic shooting, the history behind it, how this works, what are their characteristics, define some concepts, explain the relation with physics and sport, and why this works, also show some examples and formulas in order to calculate it.
Exist two types of parabolic shots, the horizontal and the oblique. The horizontal shot is characterized by the curved path that follows a body beginning, thus horizontally into the void, result of two independent movements. A horizontal movement will contain speed and vertical movement that starts with speed at zero and will increase in proportion to another body place falling from the same point at the same instant. The formula for the next is dh equal to fst, where dh is horizontal distance, bs is horizontal velocity, and t is time. Then the oblique shot. This is characterized by the path of the body follows when the thrown at initial velocity, that makes an angle of zero with the horizontal axis. The vertical and horizontal components of the speed have a value of the beginning the movements that calculated with following formula. BOV equal to BO sin of 0 and BH equal to BO cos of 0.
The first scientist to talk about this was Niccolò Tartaglia in 1537. He published a book called La Nova Scientia, in which he describes the trajectory of the projectile as if it were an initial straight line and a subsequent fall. At first, he doesn't believe in their own theory, but he creates formulas and tools like some special abacus that tabulate the calculations of the shooting. It were until 1638 when Galileo Galilei proposed his parabolic shooting model, when this became a popular discovery, but Galileo doesn't include the fact of the error resistance in the new calculations, so the people prefer to use the Niccolò ones. In the 18th century, the scientific and military engineering Benjamin Robbins continued the investigation of the parabolic shooting. He designed a machine that shows the impact of air and gravity in a projectile, and why when we throw one, it makes a parabolic shape. His researches and the ones of the other scientists contribute to the information and formulas that we have nowadays.
Well, I'm going to talk about three formulas and one example of the parabolic shot. To start, the first formula is to know the maximum height that the object reaches, and is this one. And the second formula that I found is the formula to know the time that it takes to climb and it takes to fly. And well, is this one, the second one. And the last one is the third one, is to know the horizontal range, that is pH. The following formulas represent that these ones. Well, now I'm going to pass to talk about one example of the parabolic shot that is in the game of basketball. Well, this occurs when any player of the in the court shooting of any angle of the court towards the basketball, since when shooting towards the basketball, the ball what makes a distance, a trajectory that with starts in the initial point that is in the hand. Well, this makes a distance that we can say is a parabolic. Well, we could teach like all the characteristics and how the parabolic shot works, but my partner will demonstrate it with a Angry Birds game. So that was all of my part.
Well, to start with the experiment, we just need to download the app of Angry Birds, or you can go to the browser and search online. It's okay too.
Before I start, I would like to summarize what is the game about. Well, it's about a bird that is released by spring and has to throw the house pigs to win. And the objective of this app is to verify that the jumps and the throws respond to the law of gravity. That means we have to verify the acceleration is constant, vertical, and downward. As my team already said, the parabolic has two types, the horizontal and the oblique one. The horizontal one is characterized by the curved trajectory that follows a body, and the oblique is characterized by the trajectory that follows in a body when it's thrown at initial speed and forms an angle with the horizontal axis. So that means that the more we stretch the speed, the further the bird will go. And if we stretch it less, it will not reach the acquired distance.
General idea. The game is based on shooting birds, which acts like projectiles to destroy the glutton's pigs that have stolen their eggs. And how could it be oversight? The best way to achieve it is in a parabolic shooting. And the purpose is to make people interested in learning physics in a fun and not boring way. That is why we do this application is perfect, since most people spend their time on a cell phone, and it's better to spend the time in apps that help the people to do another things, in this case of physics. And it's a fun way to explain a parabolic shooting in a physics classroom. And this is the game is Angry Birds. And if you play, you also learn. This is very important. And this is so fun.
Hi, I am Mao, and I will give you a little explanation about the parabolic shot. The parabolic shot is made by any object whose type is bent parabol, and also it starts with the union of the movement that have the horizontal components and the movement that have the vertical components, which are carried by gravity and that form a parabol structure.
Horizontal shoot. It is characterized by the curved path that follows a body when it is thrown horizontally into the void. Vertical shoot. It is characterized by the path that a body follows when it is thrown at initial speed that forms an angle theta with the horizontal axis.
Exists two types of parabolic shoots, the horizontal and the oblique. The horizontal it is characterized by the curved path that follows as a body behind thrown horizontally into the void, the result of two independent movements. A horizontal movement with constant speed and a vertical movement that starts with the speed 0 and goes increasing. In proportion to another body left falling from the same point and at the same instant. The formula is the net where dh is the horizontal distance, BH is the horizontal velocity, and T fall time of light shot. It is characterized by the path that a body follows when it is through at the initial velocity that makes an angle of zero with the horizontal axis. The vertical and horizontal components of speed, they have a value that the beginning of the other movements that is calculated with the following formulas. The formula for knowing the maximum height that the object reaches is this. The formula for knowing that the time that takes to climb at the time it takes to fly is this. And to know the horizontal range dh, the following formulas are used. This.
The parabolic movement or oblique shoot results from the composition of a uniform rectilinear movement, or standard arm UARM is uniformly accelerated rectilinear motion, and a uniformly accelerated rectilinear movement of traveling up or down, vertical UARM. The equation of MRU for x-axis is x is equal to x0 plus velocity by x by time. The equation of MRUA for the y-axis, By is equal to B by y plus AY by time. The equation of motion resulting from the composition of a uniform motion along the x-axis and uniformly accelerated motion along the y-axis are as follows: a x is equal to 0, ay is equal to minus g, bx is equal to v0 by cosine of the degrees. By is equal to v0 by sine of degrees minus gravity by time. X is equal to velocity initial by cosine by time. Y is equal to velocity initial by sine by time minus 1/2 gravity by time to square.
Hello, my name is Alejandro Ochoa.
I am Juan Pablo.
I am María José Coto Pacheco.
I am Nicole Hernandez.
Hi, my name is Pedro Lich Luis.
I am Octavio Ortega.
I am Juan José Vázquez.
Hi, I am Eduardo Juárez.
Hi, I am Elias Guerra.
I am Alexander García Prieto.
I'm Jeremy Corona.
And today, my team and I are going to be talking about vectors and their characteristics. So, in the following presentation, we're going to be explaining this mathematical entity in all its aspects and capacities in order to make this concept as clear as possible, regardless of whether it is used for mathematics or for physics. First, we're going to go through the explanation, which will help us to understand vectors' general objectives, such as the use of the mathematical basis to apply the concepts of vectors, or even to apply operations graphically with this entity. With the help of the explanation, we will make clear vectors' components, as well as some formulas and algebraic operations to help you solve algebraic equations and to calculate some values.
In this second phase is the background in which we are going to be explaining in more detail all the components of the vectors. At first, we are going to explain what is a vector, what is a physical, scalar, and vectorial quantities supported by some images to have a better understanding of the topic. Also, we're going to explain some formulas and how to solve them to have the basic knowledge of the topic.
Vectors. The word comes from the Latin word vectors and veho. Vector is defined as a mathematical entity which is graphically represented by a line segment that has a defined orientation in space. Has two independent properties, magnitude and direction. Magnitude can be shown as the length of the line segment and direction as the orientation of the line segment that an arrowhead points to one end. Vectors can be depicted graphically into 2 or 3 dimensions.
I'm going to talk to you about the components of a vector. Each part of two-dimensional vector is known as a component. The components of a vector depict the influence of that the vector is a given direction. In much the same way, a single vector can be broken down into a number of vectors which when added give the original vector. These vectors, which sum to the original, are called components. Then we have the magnitude. The magnitude is nothing more than the length of the vector. But also we have the direction, and the direction is the measure of the angle it makes with an horizontal line.
Vectors, we're going to use some specific formulas that are the following ones. AX is equal to A, that is our distance, by the cosine of the degrees. And BX is equal to B, another distance, by the cosine of the degrees. For finding BY and BS, we're going to use another formulas that are the following ones. AY is equal to A by the sine of the degrees. BY is equal to B by the sine of the degrees. After finding AX, AY, BX, and BY, we're going to use the other formulas to finding RX and RY. For getting RX, we're going to use the formula that is AX plus BX. And for finding RY, we're going to use the other formula that is AY plus BY. And for finding the displacement, we're going to use the simple formula that is square root of Rx to the second power plus Ry to the second power. And for the direction, we're going to use the formula that is tangent minus 1 by Rx over Ry.
Now, the activity. In this part of the video, my teammate will exemplify the application of vectors using a video game called Minecraft. Well, we chose Minecraft to exemplify or to facilitate its comprehension, doing a treasure hunt, with the purpose to make the public understand the application of vectors. Also, we want to show you what we have learned in class, and of course, prove that vectors are used in daily life. Now, we will proceed to the list of materials and procedure.
Well, now I'm gonna be giving you the list of materials required for this activity. For this activity, we're only gonna be using 3 materials. The first material is a computer with the game Minecraft on it. This material helps the activities to be much more fun. The second material is gonna be a screen recorder application to capture all the process of the activity on video. And the third material is just a sheet of paper where all the procedures and data are going to be written.
First, the player will receive angles of and scale measures of a block. Next, the player will walk from the starting point to treasure 1, thus this way up to the treasure 3. Finally, by obtaining the components of each displacement that the player did, it will calculate the total displacement.
A pirate is searching for an Aztec treasure lost thousands of years ago. The pirate has been searching for it for over 1 year. He is pretty close up to the treasure. He found a treasure map that guides him to the treasure route.
When he finds the spot, he sees that he has to make a displacement of 45 degrees to the northeast. He moves 30 blocks when he finally finds the first treasure.
Following the map, he sees that he has to make a second displacement of 36 meters, 30 degrees to the northwest. To get the last treasure, he makes a displacement of 18 meters, minus 60 degrees to the southwest.
To conclude, the pirate displaced 30 meters at 45 degrees in the direction to the northeast. Then, the pirate displaced 36 meters at 30 degrees in the direction to the northeast. The pirate makes a final displacement of 18 meters at minus 60 degrees in the direction to the southwest.
The pirate makes a total displacement of 65.78 meters at 201.044 degrees to the northeast.
Hey, we're almost in the ending. So, what we have learned about all this, we have learned that, yes, what is a vector, where the vectors come from, and how to calculate a vector. But what we really learn about this? Okay, we learned that, yes, vectors are used in physics and mathematics and other exact science, but we can also use it in our daily life. For example, when you're pulling something with some direction, you're using a vector. When you're walking in some direction, you're using a vector. Wherever you use magnitude and direction, you're using a vector. So yes, as a conclusion, we can give that we have learned that vectors are used in exact science, but we can also use this in our daily lives, even we don't notice about it.
My name is Adriana. I'm a girl with no mask because I don't know where I live. But my team and I are going to present to you one of the basic laws of physics, the law of conservation of energy, and how roller coasters are involved. So,
Assistant, where do you put my time machine? Oh, hi. Who are you and why are you here? Oh, you came for learn about energy conservation. Yeah, I remember. Okay. We need to know about that. We need to explain certain keywords and basic knowledge to know why this happens. The process of how a car can buy conserving energy. Well, first keywords that we need to know about to learn about this topic. Okay, but we have its closest system. system. The gravitational potential energy store, kinetic energy store, magnetic energy store, electrostatic energy store, and fitting. The elastic potential energy store, also thermal energy store, chemical energy store, and also the nuclear energy store. Basic knowledge to know how this process can work. Thank you very much, and see you another day.
Hi, I am Aime. Have you ever wondered how the conservation of energy works?
What?
Well, I'm very glad here. My team and I are going to give brief theory about what is conservation of energy and also what is energy. We're going to make this through a brief experiment of a roller coaster. We're going to show you how the roller coaster is related to the conservation of energy. So I really hope that you learned something new.
All the information necessary related to the conservation of energy, and the second one is creating a workshop where the person will learn the conservation of energy through a roller coaster. So let's start. The concept of matter, motion, and energy have occupied the minds of philosophers and scientists since ancient times. Although there were many who believed that mass and energy are conserved, it took many years until the first law of thermodynamics acquired its present form. The law of conservation of energy is one of the fundamental principles of the physical world as it understood it.
Conservation refers to something that does not change. This means it has the same value before and after an event. The law of conservation states that the energy is neither created or destroyed, it only transformed. The total energy is constant in any process. It might change in form or be transferred from one system to another, but the value it always remains the same. Roller coaster is converting gravitational potential energy into kinetic energy and speed.
Kinetic energy, what is? Is the energy that a body passes because of its motion. It is the capacity or work that allows an object to go from being at rest or still to move at a certain energy. An object that is at rest will have a coefficient of kinetic energy equal to 0, but when the object moves and accelerates, the kinetic energy increases. And in order for it to stop moving, it must receive the same amount of energy that has set in motion. This can be negative or positive. The potential energy is the energy that an object possesses due to its position in a force field. It can also be due to its configuration of its parts. This energy has its scalar quantity on the international system of units, that is the joule. An example of the kinetic and potential energy is in a balloon. When the balloon blows up, it is the potential energy like this. And when the balloon deflates, is the kinetic energy. Free fall is the motion of an object where gravity is the only force that can act on it. An example is where Isaac Newton discovered the gravity with the apple, and this is a legend that says that the apple was on the tree, and then it falls on the head of Isaac Newton. The gravity acts on the apple, and this is called free fall. The mechanical energy is the sum of kinetic and potential energy in an object that is used to do work. It is the energy on an object due to its motion, position, or both. An example of the mechanical energy, it can be a car on motion. Height and time, these two terms are related to free fall because the height is the initial position where the object is put, and the time is how much does the object takes to fall.
Hi, I'm going to explain the figures of the energies during the most famous roller coaster in Mexico, that is Superman. So here the wagon is at the highest point, so the potential energy is at its highest value, but the kinetic energy is equal to 0. However, when it drops, this terrifying drop, it's losing potential energy, but gaining kinetic energy. It is in the down, the kinetic energy is at its highest value and the potential energy is equal to 0. But when it's increasing, both energies are almost balanced in this point. Thank you.
The only way that the world can work is by energy. This energy comes principally from the plant fossils. Not all are from dinosaurs. I think. The law of conservation of energy states that within a closed system, energy can change the form, but it cannot be created or destroyed. To work, it uses kinetic and potential energy. The kinetic energy is all the energy that the objects get from the movement, like that kind of movement. And the potential is the energy that an object gets from the position, and all the energy is stored there. For example, now I'm in a swing, so this is like a kind of potential energy. When a roller coaster moves, what happens is that when it is at the top of the first hill, all the energy already got in a travel to it is storage, and it is the energy that all causes for all the road. Usually, the cars go up with the help of a chain, and when it's time to go down, the chain goes down, and the potential energy transforms into kinetic energy.
Well, now, how is energy conserved in roller coasters? Well, in energetic terms, its gravitational potential energy is transformed into kinetic energy, as we already know, that is associated with the movement of a body. Esto es Francesco Bernoulli.
Francesco!
Except for a small part that is transformed into heat due to the friction exerted by the air and the ropes. Now we have transformed. How does potential and kinetic energy work on a roller coaster? Well, if you pay attention to me, now we know that the roller coasters work by converting gravitational potential energy into kinetic energy, speed, and so on. And gravitational potential energy is which increases as a body moves away from the Earth, that is, getting high. So, a factor that helps out to this is the centripetal force. That is the force that attracts a moving object in a curvilinear path towards the center of the curvature.
Here we can see how potential energy goes from high kinetic energy to low one. Here we can see how potential energy goes from low kinetic energy to high levels.
Here we can see the net force and the change of magnitude of the velocity.
Oh, hi! I see that you already finished your theory from the conservation of energy. Now it's time to do an activity. You are going to be the one that controls the roller coaster. You already know everything about the roller coaster and the conservation of energy. For that, you are going to load an app. In that app, there are all the instructions that you need to follow, but for that, you need to do the first 3 levels. After that, you are going to upload a screenshot or saying in the chat that you already finished all that.
Well, doesn't time flies? We are right now at the end of our session, but what we have learned today? We have seen the main concepts that make the roller coasters work. These concepts work in our daily life, and without them we cannot do many things. These concepts are
The centripetal force, acceleration, kinetic energy, potential energy, and mechanical energy, and freefall. We don't perceive them, but they are present everywhere, and with our experiment, we can prove this concept presence. Now we know the roller coasters are not only funny, but also scientific.
The laws of Newton affect us and everyone around us. They are present in the most simple things. Sometimes we don't remember that they exist. They can be when you push a box, when you throw a ball, or when you are playing with marbles. Also, when you are in a fair and you want to play with bumper cars. But what exactly happened that caused these kind of reactions in these objects? In the workshop, we want to demonstrate how the third law of Newton affects daily life with a very interesting point of view. Also to demonstrate how fun is to learn about physics with interactive activities that are easy to do and to follow. We expect that with this workshop, you will know more about one of the laws of Newton.
General objective. We are going to deepen in the study Newton's third law that Sir Isaac Newton did in 1867, taking account the points concept, definition, and the sector that this law is talking about. We will promote its basis and the way in which this law is related to our day-to-day. We are going to represent this topic in bumper cars to explain how this law is commonly everywhere and the way it graphically works. Also, we are going to give common examples to clarify the idea. Specific objective. We will be representing this law in bumper cars, how it works, in what consists, and the relationship with this law. The main idea is to give an example of this law in something simple but have a background on it. To do this, we made a workshop as a representation with images and specific explanation. In the workshop, we will be explaining to you how we made the bumper car and do the experiment to get the final result.
Born in Lincolnshire, England, in 1643, in a peasant family. In 1661, when he was 17 years old, he began his studies in the Trinity College, and 3 years later, on 1664, he started thinking about leaving a mark on the mathematics. Among his discoveries, we can talk about the principle of differential and integral calculus, investigations about the light, and the fundamental laws of physics. He was professor for many years, specific 13 years, but he left the post to become director, and in 1705 he was elected president of the Royal Society. In 1727 he died because of unknown disease. Talking about the Newton's law, specifically action-reaction, an example that we can have in our day-by-day is the one when we drive a nail and also when we are playing in a swing.
The English physicist, mathematician, and astronomer Sir Isaac Newton depend on the studies of Galileo and Descartes, published in 1684, the first graded work of physics, Mathematical Principles of Natural Philosophy, also known as Principia. In the first of the three parts into which the work is divided, he exposed the relationship between forces and their dynamic effects in three laws. The laws of dynamics. Starting from his studies, Newton developed dynamics, a science that deals with the relationship between the forces at the moment that originated. In the second section of the Mathematical Principles of Natural Philosophy, he published, at the insistence of his great friend and astronomer Edmund Halley, Newton established, after a series of definitions, the three axioms or laws of movement.
And I'm going to explain about the third law of Newton, and I'm going to give some examples of it to explain it better.
This law says that every action has a reaction between two objects. It suggests that these forces occur in pairs which magnitudes and directions are equal and opposite. To demonstrate this, the balls crashing is the action, and the reaction is the balls changing their trajectory, as we can see, and then they are going to falling down. As we can see in this image, the rocket is going to eject fuel, and this fuel is going to hit the ground, and the rocket is going to elevate because it's going to boost the rocket to the sky. In these examples, we're going to see two balls that they are going to crash at the same time. First of all, this is the action, where the balls they are going to crash, and the reaction is going to be that they are going to stop and they are going to suffer a change of velocity.
About the application of the third law of Newton in bumper cars. Well, this law talks us about action and reaction in the bumper cars. This is applied when the cars crash. Well, imagine that this car and this car, well, they are at, well, they have the same speed and they directly crash. Well, uh, this law is applied where if both cars crash, they are not, well, the the force that they have will be annihilated, and well, the cars will stop just like this. Like this. That's, well, imagine that this car is going like this, and this one uh, crashes like this. Obviously, because this car don't have a force in the way, in the same, well, in the opposite way that this car is going to be pushed, and this is going to be like the winner of that crash, just like this. And well, that's basically the way the third law of Newton is applied in the bumper cars. Thank you.
For this experiment, you will use scissors, wood sticks for bottle caps, a straw, of plastic tubes, a plastic bottle, Sharpie, a balloon, glue, a screwdriver, color markers if you want to decorate the card, and Durex. For the first step, you need to peel off the label of the plastic bottle and mark 4 dots with a Sharpie in each side of it as is shown in the video, because after that, you will take the screwdriver and put it over the oven for heat it up, because this action will allow us to make holes into the bottle. And of course, we are going to repeat this step in all the dots of the container. The next step is to break the wood stick and straws into two, so you can check where are going to be the holes, and also make another dot for the screwdriver and the stick that will push through. With the help of glue while they are drying, do another sign at the end and top of center of the flask, because once again we are going to make a space into there or the tubes, where in the end of it will be a balloon sealed with Durex. Also, don't forget to do a taster for checking if the balloon or straws aren't broken. After that, grab your bottle cap, put it through the other holes towards adding the other piece with more glue, and like this is how the bunker car should look like. Don't forget that you can do how many you want for crushing them with each other, or dash it with the wall, as I did, because the balloon will be the stopping method our car is using.
For every action, there is an equal and opposite reaction. When one car hits another, it is simultaneously receiving a blow that propels it backwards. It doesn't matter if one of the cars is stopped. It exerts the same force on the car that just hit it. Both cars and passengers conserve their kinetic energy by making a type of rebound that does not alter bodies. If two bumper cars traveling at the same speed and carrying the same amount of weight run into each other, they will bounce off and move an equal distance away from each other. However, if there is a difference in the amount of weight being carried in the two cars, the car with less weight will get bumped farther away from the point of impact than the car carrying more weight.
Two experiments related to Newton's law. For understanding how they will be related with the laws, I'm going to introduce you to the three laws. Well, they are also known as the Newton's law of motion. As I already said, there are three laws. Well, the first one tells us that an object will not change its position unless a force acts on it. The second law says that the force of an object is equal to its mass times its acceleration. And the last one, the third, is when two objects interact and they apply forces to each other of equal magnitude and opposite direction.
The objective of our project is to find the scientific explanation that exists behind the magic tricks through the use of the physics in order to present a didactic learning model. To find the relationship between physics and magic, we are going to carry out a series of investigations and experiments. This didactic learning model helps you to easily understand of the physics topics, helps you to find the relationship that exists between the real world and the physics, and help you to recognize the importance of the physics in our daily life.
Well, now talking about the specific objective, as you already know, we're talking about the laws of Newton. Here at the right side of the presentation, we can appreciate the three of them with a little bit of an example and their definition. Well, for starting, we want to give you a little bit of a background of Isaac Newton. Well, he was born in the city of Manchester, England, in 1623. He is widely considered as the most influential scientific mathematician of all history. He also wrote books about his achievements and a little bit of stories, but he didn't got a lot of luck in that side of writing. Well, he discovered his laws at 1666 at the age of 23. He passed away in the year 1723, starting with different projects that sadly he never accomplished to finish because of his death. Well, now talking about the important part, our objective. Us as a group in our presentation, we don't want you only to understand why we got the final product in different experiments you will see about the laws. We want you to understand the importance of each law in daily life. Even though we don't see them, they're pretty important and they have a direct impact in your life in each moment, 24/7.
The first law of motion states that every object persists in a state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Basically, what this law is trying to explain to us is that if there is no net force acting on an object, then this object will remain in motion. And if the velocity of the object is zero, then this object will remain in rest. An example of this first law could be a ball in a stationary position. Without an external force acting upon it, the ball will not move. The same thing happens with a ball in motion. If there is no external force acting upon it, the ball will continue its motion.
Inversely proportional to the mass of an object for equal forces. A heavier object will experience less acceleration than a lighter object. The velocity, force, acceleration, and momentum have both a magnitude and a direction associated with them. This is called vector quantity. All the equations can be applied in each of the component directions. In general, an object moves in three different directions that are up, down, left, right, and forward, back. Motion of aircraft resulting from aerodynamic forces, aircraft weights, and thrust can be computed by using this Newton's second law of motion. Pertains behavior of objects for which all extending forces are not balanced.
Newton's third law is for every action there is an equal and opposite reaction. This states that for every action in nature, there is an equal and opposite reaction. For example, if an object, let's put the name of the first object, exerts a force to another object, let's put the second object, then the object will exert an equal force on the first object. Both forces are exerted on different objects. The force exerted by the first object is called action, and the force exerted by the second object is called reaction. The size of the force on the first object equals to the size of the second object. The direction of the force on the first object is opposite to the direction of the second object. So forces always come in pairs, equal, and opposite reaction, force pairs.
For the first magic trick, we'll need 5 things. 3 glasses, some water with colorant, 3 toilet paper tubes, a plastic tray, and 3 eggs. First, we set up the place. We start by filling a 3/4 of the glass with water. Then we prepare the place where we will place the structure, which consists of the glasses of water, the plastic tray, and the toilet paper tubes, one over another in that same order. Over the tubes, which stand vertically, we'll put the eggs and then proceed to perform the experiment. We'll have to hit the tray as sharp and fast as possible so that the eggs that stayed at rest graze with the toilet tubes and then proceed to free fall to the glasses, which will be full of water so that the eggs don't break. This is all thanks to the net force applied, which in this case will be none, that the eggs will continue to stay at their place and won't seem to be affected by the tray.
For this experiment, we will use a glass, a candle, a lighter, some water with colorant, and a plate. First, we need to put the plate in a place where we cannot have accidents. The second step is to place the candle in the middle of the plate and be sure that the candle would not fall when we add the water. The third step is to turn on the candle very carefully with the lighter. After that step, we will need to add some water. After that, we will need to add 2 drops of colorant and mix it very well. But remember, we don't need to fill completely the plate, but we need to add a big quantity to see the effect. The last step that we need to do is to wait some seconds and put the glass over the candle. This experiment will be developed and you will see that the water gets up into the glass. This happens because the candle turns off and because of the temperature. The pressure inside the glass is less than the one outside, that is the atmospheric pressure. As a result, the atmospheric pressure is higher than the pressure inside the glass, so the pressure outside wants to cover the space that was used by all the oxygen and makes a kind of push to the water. And the resultant of this is that the water level inside the glass increases. And this is how the experiment works and how physics is involved here.
For this experiment, we are going to use 2 plastic bottles, a cork, a cord, 2 skewer sticks, baking soda, vinegar, toilet paper, and adhesive tape. Step 1. We must cut a bottle in half and join it with the other bottle with adhesive tape. Step 2. Cut the sticks in half and paste them to the bottle that is complete. Step 3. In the toilet paper, add a tablespoon of baking soda and tangle it so that it doesn't come off. Step 4. In the bottle, add 20 milliliters of vinegar and then put the toilet paper where the lid is, but try not to fall off. And then put the cork on the top. Finally, put the bottle like in the video so that the vinegar falls on the baking soda. This reaction occurs because combining vinegar and baking soda produces a large amount of carbon dioxide and creates a strong pressure that makes the bottle fly.
Hi, we are Team 15 from third semester and we will explain friction and Newton's second law. Friction and Newton's second law are applied in our daily lives. However, not everyone knows what they mean or how they behave. In consequence, in the next minutes, these two concepts will be explained along with the relationship and behavior. First, we will give an introduction to know who Newton was and what his 3 laws are, focusing the explanation in the second law. Then we will explain friction, mentioning its different types and formulas. Therefore, we will also mention some examples of friction's daily life application. And lastly, as a conclusion and to demonstrate friction's application, an experiment will be carried out using static and kinetic friction in different objects and surfaces. So, put attention and enjoy the next minutes.
Talking about the general objective that we as team proposed to ourselves, we said that we're going to analyze the relationship between the friction and second Newton's law of motion in bodies. This is our specific objective. We're going to make different types of material objects slide, taking into account 2 very important things, like static friction and kinetics, over the surface of a cardboard, raising it progressively with a rope. And I say this because our aim also is to understand how friction and motion may interact with our daily life situations by the presence in common activities, such as this.
Sir Isaac Newton was born in Worcester, England in 1643. He grew up in an era where Renaissance thinkers were challenged by new discoveries and they were doing new experiments. He was enrolled in the Cambridge University, but during the Great Plague he had to return to his home. This is when he created 3 laws of motion and universal gravitation, which states the following. Number 1. Every object in a state of uniform motion will remain in that state of motion unless an external force acts on it. Number 2. force equals mass times acceleration. And number 3, for every action, there's an equal and opposite reaction. But that wasn't all he did. He was known for being a mathematician, astronomer, alchemist, philosopher, and inventor as well. He studied telescopes, color, gravity, etc. We now know him as the father of calculus and physics.
The second law of motion. This law implies that if there is not applied force, then the acceleration would be equal to zero, and that acceleration will only happen when there is a force being applied to the object. Riding your bicycle is a good example of this law. Your bicycle is a mass, and your leg muscles pushing on the pedals of your bicycle is the force.
To explain the reason of how things move in real life is easy and it's called friction. Change means movement, movement means friction. This was said by Linsky in 1971. Friction is a non-conservative force which acts in the opposite direction of an object's motion. Now without it, it will be almost impossible to do tasks such as hauling a mug. This force can act in any material that we use on a daily basis by holding back the movement of the object. There are 4 types of friction. The first one is static friction, which prevents the objects from moving to one place to another one. The second one is rolling friction. This is the weakest type and it involves wheels or balls, and it occurs when they are slowing down its motion. The third one is sliding friction. This one happens when 2 objects are rubbing and opposing each other. And the last one is called fluid friction. This type of friction occurs when the fluid layers move relative to each other, and it comes in different shapes and sizes.
I will talk about the different friction formulas that physics has. The first one is the friction formula, where F stands for force of friction that is acting in the object, that is equal to coefficient of friction by normal force acting on the object. Then we have the kinetic friction formula, where Fk stands for frictional force that is equal to coefficient of kinetic friction by normal force. Then we have the static friction formula, where Fs stands for frictional force less than or equal to coefficient of static friction by normal force. Then we have rolling friction formula, where Ff stands for resistance toward the rolling objects that is equal to force of the rolling friction according to the total weight of the object by reaction of the object. Then we have fluid friction formula, where friction is equal to fluid viscosity by area of the top plate by velocity of the top plate over separation of the 2 plates. At the end, we have the sliding friction formula, where Fs stands for force of sliding friction that is equal to coefficient of sliding friction by normal force.
Examples of their applications in everyday life situations. Now that we understand these terms, it is important for us to acknowledge how prominent friction and motion can be in our daily lives. Motion, being the action or process of moving, may intervene, for example, as someone is practicing archery. In this case, he or she would use the arc to pitch the arrow by tensing the arched thread, causing the arrow to have a rectilinear motion to get to the target. On the other hand, we have friction, which we experience way more often than we realize. For example, when a baby uses a crayon, the harder he presses it, the darker color he'll get. This way, he's employing friction by rubbing the crayon against the paper. A different example we commonly experience is brushing our teeth. In this case, we employ the toothbrush and the toothpaste to remove the plaque of our teeth. We are again rubbing a soft material against the hard material.
General idea of workshop. Friction. Friction is the contact of 2 objects. The coefficients of friction will be demonstrated by sliding different surfaces over each other with a change in angle. In this case, we have one object, different angle, and here we have another object with a different angle. Static and kinetic frictions will be present. Static friction is the resistance force that is present when the object is in repose. That is why this force opposes when the movement starts. Kinetic friction is the force of resistance that is present when the object is in motion. This force opposes the movement of the object.
The purpose of this experiment is to demonstrate the difference in friction's behavior depending on both the surface and the type of material in motion, studying their conduct and showing how even the flattest surface has a hardness even if it is at a microscopic level.
Hi, now we're going to test the friction with this experiment. The materials we're going to use are a piece of thread, a large paperboard, it's going to be the trick serial, a square base, a protector, a piece of wood, a piece of sandpaper, and glass. We're going to put the objects on the large paperboard, pull the thread, and measure at what angle they come down. So let's do this. We're going to start with the wood. Okay. 10 degrees. At 10 degrees, the wood came down. Now we're going to use the glass. Five degrees. At 5 degrees, the glass came down. And now we're going to test the sandpaper. 30 degrees. At 30 degrees, the sandpaper came down. Now my partner is going to explain why the friction affects the falling of the bodies.
Thanks to all of the information given by my teammates about the topic, we can conclude that the friction is a reaction that occurs in the contact between two bodies or surfaces. For a better understanding, we have prepared for you an experiment where the coefficient of friction will be demonstrated by sliding different surfaces, one over each other, with a change in the angle in order to obtain different results. At the time that the experiment is performed, two types of friction will be observed, static and kinetic. Static friction is a resistance force presented when the object is in repose. This is why this force opposes the movement when it starts. And kinetic friction is a force of resistance that is presented when the object is in motion. This force opposes the movement of the object.
Hi, we're team number 12, and my team is confirmed by Uganza Machado Alejandro, Dorothy Miguel Ángel, Henry Vegán Becaila, González Hernández Gerardo, Miranda González Griselda, Ojeda Garzón Gerardo, Sánchez Vázquez Daniel Alejandro, Santos Caustera Iker David, Santos Reyes Andrés, Vázquez Orduña Diego, and Rojas Morales Diego André. And we are going to explain the topic Newton and the motion of the planets, that consists in the gravity and the Newton's second law. And now, I will let my classmates, Kyla and Diego Vázquez, to give you a brief introduction to this topic.
Okay, we are going to talk about Isaac Newton. Isaac Newton has been one of the most important physical in the human history. He meant a lot of things, and even he poured a lot of physics and mathematics. But Newton had an easy childhood. He was son of a poor landowner. He died when he was a kid. When he was 3 years old, his mother get married with another man, living with his grandmother and stay alone with her. Years later, he started to go to Cambridge, to the University of Cambridge, and study philosophy. But years later, he has a lot of interest in physics and maths. So when he finished the university, he discovered all the laws that he presented to the Council of Cambridge. And years later, the world starts knowing the name of Newton. And in the year of 1727, he died for a kindly colleagues and health problem.
Better known as the father of physics, Isaac Newton is known for his contributions to humanity as well as science itself. His contributions were the famous 3 laws and universal gravitation. Gravitational law consists of the fall of the bodies on the Earth with the correct value of gravity, in addition to the fact that the inertial and gravitational masses were of the same nature.
He first came up with the idea or thought while he was on his way towards a meeting at the university he taught at. He saw an apple fall from a tree. Without any reasoning, in his brain flashed the thought that the fall of an apple and the movement of the planets in the orbit must obey the same universal law. This thought allowed him to process a new, more mechanical philosophy, and he created hypotheses from the comparison of planetary movements, thus developing a new theory.
Now, let's continue with Gerardo Ojeda and the scientific Alejandro Buganza, who are going to give you the objectives of this project.
Hi, my name is Gerardo Ojeda Garzón, and today I'm going to ask some questions to a scientific from the NASA, Alejandro Buganza. Hi.
Hi.
The first question is, why did you choose this topic for your experiment?
Well, in the NASA, we try to look always to the future, and we think that this topic of the projectile motion is very interesting for the society and will help to know more about physics and how it relates with the planet.
Thank you. Why are you using the first law for this experiment?
Well, let me correct you, because we are not using the first law, we are using the second law. The second law of Newton states that acceleration of an object is dependent upon two forces, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the force of acting upon the object and inversely upon the mass of the object.
Right, thank you. What is the general objective?
Well, our general objective is doing a research about the second Newton's law to be able to identify and explain the law, also to know more about how the physics is related with our planet.
And the last question, what is the specific objective of your project?
Well, our specific objective is identifying and explaining the reason that the shape of the planetary orbits around the sun has an elliptical shape, and create our own sources to prove that theory is completely true.
Thank you so much for your participation.
With that said, we are going to explain the technical part of this. Well, now we will continue with Iker Santos.
Scientist Isaac Newton established three fundamental laws based on the studies of Galileo Galilei and Descartes. That are the three most law important. The first one is the law of inertia, the second one is the fundamental law of dynamics, and the third one is the action and reaction. But here we're going to talk about the second law, which is fundamental law of dynamics. Newton's second law states that acceleration that a body experiences is proportional to the force that it receives. Newton's second law tells us that the relationship between causes, force, effects, and acceleration, it does not say anything about what other factors can influence these causes. As an example, can be the force of gravity depends on the mass and distance. The elastic force depends on the characteristic of a spring and its elongation.
Griselda is now going to explain how the second law and the gravity are related to the movement of the planet.
Hi, my name is Griselda Miranda, and I'm going to explain how does the second Newton law and the force of gravity are related to the movement that the planet has around the sun. Here, I can say that the Newton's second law are related to the gravity because it's an example. But now I'm going to explain how Newton's conclude that the gravity are on the space and how does it related to our planet. Newton's wrote and described that he questioned the existence of the gravity because one apple fell from the tree and hit his head. Later, he found the relationship of the movement that the moon has with the earth and the motion of fellow objects. Newton assumes the attraction between two big bodies. These bodies can be the earth and the moon, or the sun and the planets. And he concluded that this force not requires the contact like the others laws established, like the first law. Well, thank you, that's all.
Daniel Sanchez is going to explain the formulas needed for this second law.
Okay, so after that, I'm going to explain the formula. The formula is
quite complex, but I'm gonna explain it very well. Well, the formula explains that everything and all objects have a mass. And to calculate the mass to the object, we have to divide the force dividing by the acceleration of the object. And then we have to calculate the force of an object, and we need to multiply the mass of the object by the acceleration of that object. It will be a little confused, but to calculate the force is F equals M multiplied by A. M is also the mass and the A is only the acceleration. And to calculate the mass, it's F divided by A. F also known as the force and A also known as the acceleration. So that's everything for me. We're gonna go to the next scientific.
Now, let the experts perform the experiment and they will also explain to you some things about it.
If the sun and the earth attract each other, why didn't the earth fall towards the sun? Why hasn't it been engulfed by the sun? What is the thing that prevents it?
The answer is that the Earth is falling. The magic is that the fall fails. Imagine that I grab the Sun and the Earth and release into space. What is going to happen? They will attract each other and eventually will have a crash. But what if in addition to releasing the Earth, do I give a little bit touch to the right? Well, the Earth will be attracted by the Sun, but it will move to the right, on the way impacting elsewhere.
But wait, if I hit it hard enough to send the earth out of the sun, what will happen?
Well, the Earth will fall towards the Sun as before, only that the collision will fail. It would pass by its side, rising the opposite side of the Sun, and then it would come down in it again. This peculiar way of falling and never hitting isn't known to the whole world by the name of orbitating.
Thanks to the touch that we have given to the Earth, and that it has a certain lateral speed, it will continue moving in a straight line in that direction. However, the Sun exerts an attraction on the Earth. What it does is deviate the direction in which the Earth moves, which tilts its trajectory to the next step. The Sun attracts the Earth again and returns to deviating its route. The Earth wants to continue in a straight line, but the Sun forces to curve its path forever. The forces that curve the trajectory of an object are called centripetal forces. The solar system was formed from a large cloud of material that, thanks to the gravitational attraction and enormous amounts of collisions, managed to form a rotating disk around the Sun. Over the time, the matter in the disk clumped together, forming planets and other bodies, each moving at the correct speed.
And that's pretty much it. Thank you for all watching and see you next time.